Hello dear students. In this video I would like to talk about equations and start reviewing this concept from the very basics to a little bit more complex examples and exercises. So, what is an equation? Here we see an example of equation. It is x plus 4 equals 10, and it's basically a mathematical expression that contains an incognite, in this case this letter x, but take into account that we can replace that letter by any other letter that we need, because it's just a placeholder for the number that we don't know, and in this case it has an actual value that we have to find. Okay, so in this case we are going to use x, but for other examples we can use any other letter. Okay, so this incognite, which is also called a variable, has to be found. This basic example, well, what does it mean? It means that a number that we don't know yet added with 4 is equal to 10. Okay, and if you do it with your mind, you can easily know that this number is 6, because 6 plus 4 is 10. Okay, but I'm going to use this really simple example to outline the basic strategy that we are going to use to solve this example or many other more complex exercises, examples of equations. Okay, so basically we need to focus on some things. The first one is that we need to leave the variable alone in one side. Okay, leave the variable, sorry for this letter, okay. So in this case, in order to have the x alone, we need to get rid of this 4. Okay, and take into account that this 4 is accompanied by the positive sign. In this case it's an addition, but that means that the 4 is positive. Okay, every single term of equation has the sign that is before it. So in this case this 4 is positive, and the x is also positive, because before of the x there's nothing, and when there's nothing it means it's positive. Okay, so we need to get rid of this plus 4, and the way that we can do that is by subtracting 4, basically doing the opposite. Okay, so it's something like this: x plus 4 minus 4. Okay, I'm going to do it with other color, because colors are going to be really helpful in this particular explanation. Okay, x plus 4 minus 4. Okay, so what is plus 4 minus 4? We are basically disappearing that 4. Okay, we got rid of it. So it is just x. Okay, so if we continue, it's just x. Okay, x plus 4 minus 4, it's just x. The 4 disappeared because we subtracted it. Okay, but what happens? It's supposed to be equal to 10. Okay, but since on this side we did a subtraction, okay, we did something on this side, we have to do the same on the other side. So now I'm going to use once again the red, because if here we subtracted 4, necessarily we have to do the same on the other side. Okay, minus 4 here, minus 4 here. Okay, so if you follow me here, now you're going to see that on this side it's just x, and on this side 10 minus 4 is 6. Okay, what we said some moments ago: x is equal to 6. And you may say, teacher, but I can know it just by doing it in my mind. Yes, that's true, but again, I'm using this basic example in order to explain the main strategy that you are going to use to solve more complex examples. Okay, so let's do the same with subtraction on this case. Now, let's imagine that I have now this example, this other exercise. Let's say that I have 30 equals to, now I'm going to use y minus 3. Okay, 30 equals y minus 3. So here, remember, we want to leave the variable alone. So leave the y alone. So this negative 3 minus 3 is in our way. How do we get rid of a minus 3? Well, it's easy. Adding 3. Okay? Sorry. Okay, so minus 3 plus 3, they cancel each other out. So they disappear. Yeah? So let me actually put it in another line. Sorry. Okay, 30 y minus 3 plus 3. And remember, these two cancel each other out. But remember, we did something on this side. We have to do the same on the other one. Okay? So if here we added 3, we also have to add 3 on the other side. Now, y minus 3 plus 3, it's only the y, because these two, remember, they disappear together. And 30 plus 3, it's 33. Okay, so right now, we already know that y is 33. Yes? Because if you replace this 33 here, so 33 minus 3 equals 30, that's true, so it means that our answer is right. Okay. Now, follow me with another example. In this case, we are going to use a multiplication instead of an addition or a subtraction. Let's say that we have 4w equals to 20. Okay? So, whenever you have a number followed by a letter, okay, that means that between them there's a multiplication, because always when there's no operation stated between two things, it's always supposed to be a multiplication. Okay, so always have it in your mind. Okay, so it's a multiplication. We have to get rid of this 4. Okay, how do we get rid of a multiplication by 4? Well, by doing the opposite. And what is the opposite of multiplying by 4? It is dividing by 4. Okay, so here we are going to divide by 4. So this 4 and this 4 cancel each other, because if you multiply by 4 and then divide by 4, it's like you actually didn't do anything. But remember, here you divided by 4. So you have to do the same on the other side. Okay? So now, let's continue with this. Here, it's only the w, because this 4 cancelled with this other 4. And 20 divided by 4 is 5. Yeah? So that means that w is 5. We found the result, and we can check if this is true, because remember, if 5 is w, so that means that 4 times w, which is 5, so 4 times 5 is equal to 20, which is true. Okay? Something similar can be done with the division. Okay, imagine that I have this exercise. Imagine that I say that the letter A, which is a missing number, divided by, let's say, 5, okay, is equal to 30. Okay? Well, we have to get rid of this 5, because we need to leave the variable alone. Okay, and the way that we can get rid of a division by 5 is doing the opposite, which is multiplying by 5. Okay, and multiplying by 5 here, it will be something like this. Okay, a sorry, I need to draw it a little bit smaller. Let me use the color just for you to track it easily. So remember, we multiply by 5. We can do it like this. This is 5 times a divided by 5. These two cancel each other. But if here we multiplied by 5, we have to do the same on the other side. We have to multiply by 5. Okay, and let's continue with this next step here, because I am run out of space. So on this side, 5 times a divided by 5, it's just a, because the 5 disappear with the other 5. And on the other side, 30 times 5 is 150. Okay, so that's the answer of our equation. Yeah. So that is basically how you solve an equation that only requires one step. And you may say, teacher, I learned it in another way. So I am going to address that right now. Let's say that you're going to solve this equation by other method that is really commonly thought. Which means that I am going to say it really quickly. Like, if you have a plus 4 here, you just move it to the other side, subtracting, yes? So I'm going to try to do this on this side. So if you have x plus 4 equals 10, then you pass this plus 4 to the other side, negative, okay? So it's 10 minus 4. And x is 6. And we got the same result, and it was really faster. And yes, this method is true, okay, but this is just a simplification of the method that I taught you, okay, because it's just skipping some steps, and it's letting you forget the fact that you are actually maintaining the balance of the equation by doing the same on both sides, okay, because it's like just skipping this part. Okay, it's just skipping this part, or it's just skipping this part, or it's just skipping this part, or this part. Okay, the part that you are aware that this number that was in our way now disappears, but we have to do the same on the other side. It's okay if you want to do it like that. Okay, but for now I am going to stick with the explanation of doing the same thing on both sides, because I really want you to be aware of that. Okay, in further videos, or in further videos, we can just start doing it in this faster way, but once you know that you are really comfortable doing it like this, okay, and being aware. Now, this column, I am going to use it in order to now explain equations, but require 2 steps, okay? Get rid of 2 numbers, in other words. Okay, so let's go back to, okay, let's use the b, okay? So imagine that I have this 2b minus 4 equals, let's say, 15. Okay, I'm just inventing or making up the examples on the go. It doesn't matter, okay, because they can be solved. So we need to get the b alone, leave the variable alone on this side, but we have to get rid of 2 numbers, this 2, which is multiplying, and this 4, which is a negative, so it's subtracting. Okay, we have to do it in a specific order. Okay, always the number which is together with the variable has to be taken care of at the end. Okay, so we are going to begin with this 4. Okay, let's get rid of that 4. And remember, if this 4 is subtracting, we get rid of it by adding 4 on both sides. Okay, I'm going to do it on advance. So it's 2b minus 4 plus 4 and 15 plus 4. Remember, we have to do the same on both sides. And now, these, they cancel each other. So we are only left here with 2b, and here 15 plus 4 is 19. Okay? Now, we can do it like this equation. Yes, because we are now left with only a one-step equation. Let's do it. This 2 is multiplying, so we get rid of it by dividing by 2 on both sides. Okay? So let's divide by 2 on both sides. Okay, these 2 cancel each other, and we are left with b equals to 19. Okay, sorry, 19 halves. Okay, 19 divided by 2. You can leave the answer like this. This is already a valid answer. But if your teacher asks you to transform it to decimal or transform it to a mixed number, you can do it. But right now, this is a really valid answer. So you can leave it like that. Or you can write it as a decimal, which in this case is 9.5. Yeah, 9.5. Or write it as a mixed number, which is 9 and 1/2. Can you simplify it? In this case, no. But it's a matter of choice or being aware of what your teacher asks. So this is it. This is it. That's the answer of this equation. And now, I want to. Oh, sorry. I want to introduce another thing here. Okay, let's say that I have, I don't know, maybe 9 equals 5 minus 4c. This is the equation that we want to solve. Remember, we have to get rid of 2 things, the 5 and the 4. Okay, which one are we going to get rid of first? In this case, the 5, because remember, the closest to the c has to be the last one. Okay, well, I want you to pay special attention to the signs of each term. By the way, each term is like each part of the equation. Okay, so this 9 is positive. Okay, there's nothing behind it, so it means it's positive. This 5 is also positive. Okay, there's nothing behind it. But the 4c is negative, and you have to be really careful with that. Okay, because some people think that this 5 is negative because there's a negative, there's a minus next to it, but no. The sign of the term is always behind the term. Okay, so in this case, 4c is negative, 5 is positive, 9 is positive. Okay, so how do we get rid of this 5, which is positive? By subtracting. Okay, so we have to do 9 equals to 5 minus 5. I'm going to do minus 4c. Okay, we subtracted by 5. We subtracted 5 on this side. We have to do the same on the other side. Okay, and this 5 with this negative 5, they disappear. So let's do it. 9 minus 5 is 4. And here we are only left with negative 4c. Okay, now we have to get rid of this negative 4. But be careful, because you may think, teacher, the 4 is negative, so we have to get rid of it by subtracting. Sorry, but by adding. But that's not true in this case. Because, yeah, the 4 is negative, but what operation is it doing to the c? It's multiplying. So for this case, we have to get rid of it by dividing. Okay, it's a multiplication. Yes, it's negative, but it's a multiplication. So you get rid of it by dividing by 4 on both sides. Actually, by dividing by -4. Okay, because you want to get rid of everything and leave the c alone. Okay, so these and these are gone. So on this side it's just c. And what is -4 divided by, sorry, what is 4 divided by -4? So remember, when you have a division of numbers that have different sign, in this case this one is positive and this one is negative, they have different signs, so the result is going to be negative, and then you just make the division as you normally would do. So 4 divided by 4 is 1. In this case, c is -1. That's how you do that. And now I would also like to address some really important cases where you have variables, incognates, letters on both sides of the equation. Okay, so here, let's say that I have 3, I don't know which letter we are going to use. It could be any 3n plus 7, let's say, equals to 5n minus 3. It doesn't matter, I'm just making up the examples as I go, but it doesn't matter. Okay, so what happens here when you have variables on both sides? Because remember, you want to leave the variable alone. Okay, but should I do it on both sides, only on one side? What to do? So for these cases, you have to focus on get rid of the variable on any of the sides. Okay, get rid of the variable of any of the sides. So we can get rid of this 3n, this term. I mean, we have to get rid of this, the whole term, yeah, or this 5n. We choose. It doesn't actually matter if we choose this one or if we choose this one, as long as we do it correctly. At the end, we are going to have the same result if we do it correctly. So actually, let's do it randomly. Okay, so let's throw a coin. Okay, Google coin. Or tails. So let's say that if I get heads, I'm going to get rid of the variable on the left, and if I get tails, I am going to get rid of the variable on the right. It doesn't matter. Okay, so let's flip it. Remember, head, left, tails, right. Tails. So we are going to get rid of the variable here. We are going to get rid of this one. Okay, so how do we get rid of this 5n? And you may say, teacher, here this 5 is multiplying, so let's divide. But no, because what will happen if you divide this? 5 divided by 5. You leave the n alone. And you want to get rid of it by, I mean, right now. Yes, you got rid of the 5, but you are still having a variable, and actually this is not permitted because you only did it on this part. Okay, and when you do something on one side of the equation, you have to do it to everything. This is really inconvenient because we are going to get something like 3 minus 3/5, and we have to do the same on the other side, and it's really, really messy. So this is not convenient. But okay, let's remember, 5n is a positive term. What if we subtract 5n? Let's do it. Okay, so on this side it's going to be 3n. I'm going to leave space because I'll need it in a moment. 5n minus 3. But remember, we are going to get rid of that 5n, so let's subtract 5n. Okay, so 5n minus 5n is just 0, nothing, it disappeared. But remember, we subtracted 5n here, we also have to do it on the other side. Okay, sorry, yeah. So what's next? Here we are left with negative 3, okay, because these two disappeared. And pay attention here. We have 3n minus 5n plus 7. And when you're working with mathematical expressions that include variables, there's a really important rule that you have to always follow, that you can make operations between like terms, but not unlike terms. And what do I mean by all of this? It means that I can make operations between 3n and 5n because they have the same variable, but I cannot make operations between, let's say, 5n and 7 because the 7 doesn't have the same variable than here. It doesn't have a variable at all. So take that always into account. Okay, in this case we can mix them, we can operate them. And so if I have 3n and I got rid of 5n, it's like subtracting, yeah, 3n minus 5n, I end up with minus 2n, negative 2n, okay? And plus 7, we are left with an equation of 2 steps. Okay, so let's solve it. Now, I'm going to be changing color, so let's do it here. Let's get rid of this plus 7. How do we get rid of that? By subtracting. Negative 2n plus 7, negative 3. So we subtract 7 in both sides. Okay, these two cancel each other. So we are left with negative 2n equals, here, negative 3 minus 7 is negative 10. Okay, and now we have to get rid of this negative 2. So we get rid of that by dividing by 2. Sorry, I'll do it on advance. Okay, so negative 2n equals negative 10. Okay, yes, sorry, I did it like in the other order. Okay, but this, sorry, I have to get rid of this. Also negative. Remember, we want to leave the n alone. So these two things disappear, and it becomes just n. And negative 10 divided negative 2. So remember, we are making a division, and the two numbers that we are dividing have the same sign. And when that happens, when the two numbers in the division have the same sign, could be 2 positives or 2 negatives, the result is going to be positive. Okay, so have it in your mind. Now we do the division normally. 10 divided by 2 is 5, positive 5. So in this case, n is 5. And that's how you solve equations that have variables on both sides.